Now that we've introduced you to the CLI, let's take a look at configuration basics. One significant difference between the two operating systems is the way that the Junos configuration is broken into hierarchical levels. iOS configurations have some hierarchy. For example, interfaces and routing protocols are both configured in their own section of the configuration. However, in iOS, many configuration statements are global. Junos has a much greater sense of hierarchy. Rather than having a large number of global commands, the Junos configuration is broken up into various sections, one for each category. In addition, Junos supports multiple levels of hierarchy, breaking larger categories down into smaller, more specific groups of related configuration statements. In Junos, when the configuration is displayed, each level of the hierarchy is identified, and then the commands within that hierarchy are held within curly brackets. For example, a configuration that simply contains a host name looks like this. In this example, you see that the system hierarchy is identified. Then, the elements of that hierarchy follow within curly brackets. In this case, the only element is a host name. Branches of the hierarchy that are leaf nodes, that is, they do not themselves contain further sublevels of hierarchy, are terminated with semicolons. Because the hostname command does not contain further sublevels of hierarchy, it is terminated with a semicolon. On the other hand, elements that do contain further sublevels of hierarchy are enclosed within curly brackets. For example, consider what happens when we add a root password to the system configuration. In this case, the root authentication section can contain multiple elements, one of which is a password. Therefore, the root authentication element is followed by curly brackets that enclose the elements within the root authentication hierarchy. In this case, the only member is the encrypted password element, which is a leaf node and is terminated with a semicolon. It's also worth mentioning that this hierarchical configuration display causes Junos configurations to look larger and more complex than a similar iOS configuration. However, this isn't necessarily the case. Although this simple configuration fragment occupies 6 lines, it can be configured with just 2 set commands. Users familiar with the CLI could even configure that in a single set command. Because those commands are expanded into the hierarchical display you see here, the configuration looks much longer than a similar Cisco configuration. On the other hand, the way the configuration is displayed in a hierarchical fashion can make the configuration easier to read than a configuration presented in a flat format. There are a number of elements at the top level of the configuration hierarchy. Some major elements are System, Interfaces, Protocols, Policy Options, Firewall, SNMP, Class of Service, PoE, Virtual Chassis, VLANs, and Ethernet switching options. In traditional iOS, all configuration commands are immediately applied to the active configuration, also called the running configuration. This means that when you're making a change that requires multiple configuration commands, only part of the configuration takes effect until you've entered all the commands. In some cases, this design can cause undesirable intermediate states, sometimes even resulting in losing your ability to communicate with the device. And iOS doesn't have a built-in equivalent of confirmed commits to restore your access to the device. Plus, in iOS, you have no way to review your changes until you exit configuration mode and show the running configuration. Like iOS, Junos also has an active configuration, but Junos also features a candidate configuration. In configuration mode, you make changes to the candidate configuration, which starts as a copy of the active configuration. Once you have made your changes, you commit them, and they become part of the active configuration. This design feature allows you to make multiple changes to the candidate configuration and review them prior to committing them. Let's take a closer look at how you edit the configuration. By default, there is just one candidate configuration that is shared by all users accessing the device. If someone has previously made changes to the candidate configuration or is in the process of making changes, the software presents a warning message when you enter configuration mode to warn you that there are uncommitted changes in the candidate configuration. When you commit the candidate configuration, you are committing all changes made to it, whether you or someone else made them. Of course, you can always see all the changes that were made prior to committing them. If you are making changes and want to ensure that no other users can make changes at the same time, you can choose to get an exclusive lock on the candidate configuration. When you have an exclusive lock on the configuration, no other users can make changes to the configuration until you exit configuration mode. If several users want the ability to make simultaneous changes to the configuration without sharing a candidate configuration, each user can get a private copy of the candidate configuration using the configure private command. When you commit changes in a private copy of the configuration, only the changes you made are integrated into the active configuration. Any elements of the private configuration that you have not modified will not be written to the active configuration. This design means that several users can use configure private to make non-conflicting changes to the active configuration at the same time. If multiple users try to commit conflicting changes, the CLI displays an error message to the second and subsequent users who attempt to make conflicting changes. However, users can choose to make the changes anyway by committing their changes a second time. In iOS, it's possible to be running a configuration that hasn't been saved, as iOS configuration commands take effect as soon as you enter them, but are only saved to the startup configuration when the user manually saves the configuration. In Junos, there's no difference between the saved configuration and running configuration. Every time you make changes to the configuration and commit them, Junos saves the new configuration and makes it active at the same time. It also keeps old copies of the configuration, 50 saved configurations in total. You can refer to these by number and use them for various purposes. For instance, you can load any of these configurations as the candidate configuration. You can compare the candidate configuration to any of these saved configurations, and you can compare any two configurations to each other. Now we'll take a look at how you make configuration changes. First, we'll enter configuration mode using the configure command. The # prompt tells you that you are in configuration mode, and the Edit banner tells you what level of the hierarchy you are currently editing. In this case, we're at the top level, which is where you always start when you enter configuration mode. You use the Edit command to move to lower hierarchies. For example, to edit the GE009 interface, we'll enter the command Edit Interfaces GE009. The prompt is updated to reflect the changes we made. If we further decide we want to edit the Unit 0 portion of the GE009 interface configuration, we could type Edit Unit 0. The Edit command arguments are relative. Therefore, as we're already editing the interface's GE009 hierarchy, we wouldn't type Edit Interfaces GE009 Unit 0, but only Edit Unit 0. Again, the prompt is updated to show the new configuration hierarchy that we're editing. Junos allows you to configure interfaces to be part of a VLAN, but it also allows you to configure interfaces to be Layer 3 interfaces and assign IP addresses directly on the interfaces. Let's configure this interface to be a Layer 3 interface and set an IP address for the interface. You set values using the set command. We can display the values under the current hierarchy with the show command. Let's do that to see the changes we've made. Now let's say we don't want this IP address anymore. We can delete it with the delete command. Note that Family iNet is still configured under the unit. The Family iNet configuration is the Junos equivalent of the iOS IP unnumbered. If we wanted to disable all IPv4 processing on the interface, we could do that by deleting Family iNet. Deleting an element recursively deletes everything under that level of the hierarchy. You can make configuration changes at other levels of the hierarchy as well. Use the up command to move up one level of the hierarchy. Use the top command to move to the top of the hierarchy. We'll show you how to execute those same commands now from the top level. First, we'll set an IP address on the interface. Next, we'll show the configuration. This time we will demonstrate recursively deleting all of the family iNet configuration. We can also choose to show only a specific piece of the hierarchy by specifying it after the show command. This is the end of this section. If you would like to review the examples shown in this section, you can use the scroll bar to scroll through the output on the screen. Click Next when you are ready to continue. In iOS, depending on the version being used, you might not be able to run exec mode commands in configuration mode or vice versa. This design might cause you to switch back and forth between the two CLI modes as you first configure and then verify changes. Newer iOS versions allow you to use the do command to run exec mode commands in configuration mode. Like iOS, Junos has separate operational and configuration modes, and there are specific commands you can run in each mode. Like newer iOS versions, Junos allows you to run operational mode CLI commands from within configuration mode using the run command. Using this feature allows you to mix operational commands with configuration commands without leaving configuration mode. And unlike Cisco's do command, you have full access to command line completion and question mark help with operational mode commands when using the Junos run command. Let's see an example. To see a listing of interfaces from within configuration mode, enter the command run show interfaces terse pipe match GE01, or use the Type It For Me button if you would prefer to have the command. In Junos, it's easy to prepare for new equipment that is about to be installed. Unlike iOS, Junos allows you to configure ports that are not yet installed in the chassis, whether those ports are on modules that are not yet installed or on a device that will be added to a virtual chassis. When the ports are installed, the configuration will be activated. Here, we add configuration for the GE305 interface, which we will install later. As you can see from the Show Interfaces terse command, the interface is not yet installed. However, Junos allows you to pre-configure the interface anyway. You can also make configuration changes and leave them deactivated until you're ready to use them. Here, we configure 802.1x authentication to run on interface GE003. However, we leave it deactivated because we're not yet ready to begin authenticating clients on this interface. The software ignores portions of the configuration marked as inactive. It acts as if they are not even there. Here you can see that interface GE003 is not performing 802.1x authentication. When you're ready to make the change, you simply activate that portion of the configuration and the software begins using it. As you can see, the software is now performing 802.1x authentication on GE003.0. You can deactivate any portion of the configuration hierarchy, not just individual statements. If you deactivate a portion of the configuration hierarchy, the software ignores everything underneath it. For example, we can deactivate the entire 802.1x protocol section. As you can see, the software is ignoring all the configuration in the deactivated 802.1x section. We can also deactivate the entire protocol's hierarchy. As you can see, the device ignores the OSPF configuration, which is also configured in this portion of the hierarchy, and OSPF is not running anymore. This is the end of this section. Click Next when you're ready to continue. How many times have you had to move a connection to another port for testing purposes? With Junos, this process is simple. In this example, you'll move the configuration for GE005 to GE006. First, type Show Interfaces to view all interface configurations. Try that now. Type Rename Interfaces GE005 to GE006 and press. Now, type the Show Interfaces command again to view the change you made. Finally, type the command displayed on screen. This regular expression will cause the match command to display interfaces GE005 and GE006. It is easy to put the port back when we're done testing. We'll show you how that's done now. First, we'll type Rename Interfaces GE006 to GE005. Followed by Commit. Finally, we'll enter the command Run Show Interfaces Terse Pipe Match GE00 open bracket 56 close bracket to see what results. The Rename command is useful for renaming single elements. However, you might reference an interface name elsewhere in the configuration. On the EX series switches, you might do this in a VLAN, spanning tree, or even a Layer 3 routing protocol configuration. When you use the Rename command, these other references do not become updated. If you want to change all references from one interface to a new interface, such as you might do when you are permanently moving a port from one interface to another, you can use the Replace command to change the interface names. The Replace command replaces all items that match the specified pattern with a new word. However, it only finds and replaces items within the current hierarchy. Here, we will use the Replace command at the top level of the configuration to replace all references to GE003 with GE006, allowing us to move all the configuration to the new port. First, let's take a look at the current interfaces. We can see that GE003 is also configured under the Edit Protocols .1x hierarchy. Now we'll use the Replace command to replace all references to GE003 with GE006. Here you can see that the interface configuration has changed. You can also see that the configuration under the Edit Protocols .1x hierarchy becomes updated along with the actual interface configuration. What if we want to replicate an existing configuration and change only a few things? We can use the Copy command and change what we need to change. For example, to replicate the GE305 configuration on interface GE306, we copy the configuration and then change the IP address. First, we copy the interface configuration. You can see that GE306 was created. Now we edit the new interface. Finally, we change the IP address. Here is the new interface configuration. This is the end of the section. Click Next to continue. To configure multiple addresses in iOS, you would configure a primary address and one or more secondary addresses. With Junos, you can simply configure as many addresses on an interface as you want. In this case, we'll start in the GE306 hierarchy. First, enter the Show command to see the existing interface configuration. Now enter the command Set Unit 0 Family INET Address 3 times to add 3 different addresses. Each address will appear in the Try It window on screen. Enter the first command shown on screen now. Enter the next command shown on screen now. If you want to choose one of these addresses to be the main IP address for the interface, you can mark it with the primary flag. To do that now, type Set Unit 0 Family INET Address 172.20.11.1/24 primary, followed by Enter. Now type Show to see the primary address. This configuration allows you to easily manage multiple IP addresses on an interface. If you want to change an IP address, you must either delete the old IP address and add the new one, or use the Rename command to change it. If you use the Rename command, all configurations associated with that IP address stay the same. Here we rename the primary IP address. The primary flag stays configured for the new IP address. To rename the IP address, enter the command Rename Unit 0 Family INET Address 172.20.11.1/24 to address 172.20.21.1/24. Do that now. As you can see, the primary flag remained configured for the new IP address because we used the Rename command, which causes all configuration for the old IP address to be maintained for the new IP address. This behavior is very useful when you need to change an IP address to correct an error. This is the end of the section. Click Next to continue. Once you're finished making changes, you can activate them using the Commit command, as we've already seen. You have several options for committing changes. Click each button to compare your options. When finished, click the Next button to continue to the next topic. The comparison shows that the Rollback 4 configuration contains a configuration for the GE006 interface that is missing from the current candidate configuration. So we load that configuration as the candidate configuration. As you can see, the GE006 interface is now configured. If we wanted to make other changes prior to activating the configuration, we could. Otherwise, we can just commit the configuration. Before we do that, though, Have the software show you the differences between the candidate configuration and the active configuration using the Show Pipe Compare command. Do that now. Using the compare function without a specified saved configuration shows us the difference between the candidate configuration and the current configuration. So this feature allows us to see what changes will be made when we commit the configuration. Enter the commit command to activate these changes and complete this exercise.